this CADimensions webinar. Today we're going to be talking about using SOLIDWORKS PCB in conjunction with SOLIDWORKS Electrical. So we'll be dealing with a couple different softwares today and showing how they interconnect inside of the SOLIDWORKS ecosystem. All right, so just our high-level agenda today. We're going to start in SOLIDWORKS PCB and actually create a PCB. So create the board layout and put some components onto that board. Then we're going to jump into SOLIDWORKS Electrical and work on a schematic. So put a couple connectors there that are going to interface with our PCB and wire up those connectors. Then we'll jump into SOLIDWORKS and we'll actually work with that smart connector to make sure that it's going to snap to our board and that we're going to be able to route wires to and from it. And finally, we're going to route those wires. And I'll pretty much be doing edits and updates throughout the process, throughout this webinar. So it is a lot to cover. So if I'm talking too fast or if you guys missed anything, just use the question box in the GoToWebinar, and I can certainly slow down or cover something or reach out to you guys individually. All right. So like I introduced, we're going to be using 3 products today. SOLIDWORKS PCB is going to be our board layout tool, and the real goal of that tool is to interface between our electrical designers and our mechanical designers, so giving a mechanical entity to our board. Then we'll be in SOLIDWORKS Electrical Schematic. We'll be working on a multi-line schematic today using connectors and manufacturer parts. And finally, we'll be in SOLIDWORKS. So we'll be positioning our PCB inside of SOLIDWORKS. We'll also be doing our electrical routing inside of SOLIDWORKS. All right. So our end goal, not to this level of going through visualize and making sure and having all our connectors there, but what I want to show you today is what the process would be to take a board design, put a connector onto it, and route from it using SOLIDWORKS Electrical. All right, so I want to have that full assembly that's going to include the board and our wires. All right, so where we're going to start is inside of SOLIDWORKS PCB. So I'm going to use a schematic that I've already created, and I'm actually going to start to place those components onto my board. And I want that board to be somewhat specific to the assembly I'm working on in SOLIDWORKS. So you'll see me going back and forth between SOLIDWORKS and SOLIDWORKS PCB. Once I have my components placed, I'm going to route some traces using auto trace, and I'm going to just verify that layout before I push the whole thing into SOLIDWORKS. All right. So where I'm going to start is inside of SOLIDWORKS PCB. And I've already started a project called Electrical Integration, and I have these 2 control schematics right now. I'm just going to remove this guy for the time being, and we'll open up a new one in a second here. All right, so I have 2 control diagrams or 2 control schematics for this electrical project. And what I want to do is actually bring in a new PCB. So I want to start this process from scratch as far as the PCB is concerned. All right, so when I add a new PCB, I get a default board. So it's just going to be a square board that I can manipulate. What I'm going to do first is actually save this board. I want to save this as, we'll call it SWE Integration. And just because I've practiced earlier, I'll make this number 2. So my SWE Integration 2 board. All right, so what I can do once I have that board saved is I can use my engineering change order process inside of SOLIDWORKS PCB to verify or to validate and execute the components that I have inside of my schematic design. So I can validate that these are the components that are being added into my project. I can execute them, and once I execute them, you can see that the components from the schematic are now available to me on my PCB. And if I jump into 3D mode, I can start to see that these actually have components assigned to them, or 3D components assigned to them, that are going to be represented inside of SOLIDWORKS. All right. So before I go ahead and place those components, what I actually want to do is make sure my board is the right size, and I'll do that inside of Electrical. All right. So this is my default board, and I said Electrical. I want to make sure my board's the correct side inside of SOLIDWORKS. So what we'll look at next is my SOLIDWORKS assembly. So you can see here I have a workbench assembly that has, currently have a harness routed. I have a couple cables that are routed for power. But what I really want to focus on is this computer box that's missing a PCB. So I have a couple default PCBs in here. But what I really want to focus on is this missing area where I want to place my PCB. All right. So I'm just going to minimize this for the time being. And you'll notice that I have my SOLIDWORKS PCB add-in turned on. And what I can do is pull my board from the vault. So when I create a new PCB project, it's actually going to generate a project, or a managed project for me, inside of this vault that allows SOLIDWORKS PCB to talk to SOLIDWORKS. So here's my electrical integration project that I wanted to use. Oops. And let me save this guy first. Let me push him out and say starter board. And so this is just going to be our blank board to start with. All right. So it's going to see that that board is now inside my vault. It's going to ask me just to save out my project because it's going to generate an assembly of my board. And even though I only have one part, it's still going to generate this assembly because once I place my components, they're all going to fall into this electrical integration number 2 board. All right, so right now all I have is a board outline that is comprised of a board and the top face of my board. So it's going to denote what my top face is. All right, just to verify what my top face is, I'm actually going to throw just another color on top, and it's just going to be the face. So bottom of my board is going to be green, top of my board is going to be gray. This is just going to help me inside my assembly to know what's up and what's down. All right, so I have the start of my my PCB here. And what I'm going to do is we'll just minimize it and jump back into my SOLIDWORKS electrical assembly here. All right, and from here, I want to add my PCB. I'm going to go Insert Component, and we'll notice that it's already an open document, so it's going to be a sub-assembly inside of this project. And I'm just going to drop my board somewhere inside my assembly right now. All right, so now this is a free-moving component, which is actually a sub-assembly inside of this main assembly. All right, so I'm just going to snap one quick mate onto this board and make sure that the bottom is down, like so, and now I can slide this board around. All right. You can see that the default board doesn't really fit on those connection points that I want the board to snap to. So the size of the default is too small. It's not going to work for my design that I'm trying to do. I'm going to go to my top face here. And what I want to do is actually edit that original sketch. So the default board comes with this default square sketch, ends up being 100 millimeters by 100 millimeters. All right, so I want to reshape this to make sure that it's going to fit inside this area. I'm going to delete out the existing sketch. I'm going to recreate just a rectangular sketch here that's going to fully encompass those components. All right, I also see that I have a couple coax connectors coming out of here that very well could interfere with my board depending on their bend radius. So what I want to do is just ensure that there's enough room for those to have some clearance. I'm not measuring or anything here. I'm just giving a rough outline of what my board is going to look like. All right, so I'll exit out of my sketch. And that looks okay, so I can leave my component there. That board's now sitting inside of my electrical assembly. But because this is SOLIDWORKS and we're going to be parametrically connected, my board is actually updated inside of my integration, so inside of my board. And this is what I want to push back into SOLIDWORKS PCB. So updated board shape. That's what I'm going to post onto the server. It'll read it in. And now when I jump back into SOLIDWORKS PCB, I'm going to see that I have an updated shape. I have changes from SOLIDWORKS. I can view those changes. I know that it's going to be my larger board outline with that cutout, and I'll go ahead and accept it. Okay, so So now I can see that that's the shape of my board inside of SOLIDWORKS PCB. Now I'm ready to place those components from before. So I want to import those changes. I'll validate them and execute them. And we'll go ahead and close. Now what I can do is start to place those components where I believe they're going to line up. So these are my J's are my connectors that I'm going to integrate into my circuit. I can drag any connector and hit the space bar to rotate it 90 degrees. So I can start to place these along the edges because that's where I want to route my connectors to. All right. And for this example, I'm less concerned with these components because I want to focus on those connectors. So I'm going to place these components quickly and make sure that they're on the board. But I'm less concerned about optimal routing paths and cleaning up. You can certainly take some time to try to reduce the number of V's you need or reduce the number of copper. For me, I'm just trying to show these connectors for the main part. So once they're all placed and I'm inside the area of my board, I can use my tools and I can auto route all my components. Actually, before I do that, I want to add one more layer just to speed up the auto route. So I'll go into my my layer manager. And right now I have a 2-layer board. I'm going to go ahead and add a layer here, which is going to be my signal layer to the board. It gives me that 3rd signal layer where I can actually route copper through. And now I'm going to go ahead and say auto route. All right. So what our auto route function will do is find the paths between all our components based on our schematic. And what adding that signal layer does is it makes it a little bit easier to route underneath components or around components by giving it a 2nd option or a 3rd option versus just the top or just the bottom. You can now have a signal layer that can run copper in the middle of our PCB. All right. So we'll let the auto route functionality wire up this board. And once that's completed, this is the board that we want to push back into SOLIDWORKS, because this is where we're going to actually run our connectors through. All right, so just a couple left here. All right, we'll keep that going. So we created our schematic beforehand. We pushed our board to and from SOLIDWORKS. We just placed our components and we're routing our traces. Now I just want to jump into 3D, make sure that everything looks okay, and now we'll do our final push into SOLIDWORKS. All right, so everything's completed there. If I hit the number 3 key on my keyboard, I'll jump into my 3D view. And from here, I can start to see that my connectors look good from there. My copper is running into the correct pads. So I'm pretty happy with this board. I can rotate around, make sure all my vias are at a safe distance. I got no interference here. So everything there looks okay. Happy with this board. I'll jump back into 2D. And I'm going to use my PCB connector to do a final push here. So added components. We'll go ahead and post that. All right, so it's grabbing those 3D models that are associated to our components. And if I go back into SOLIDWORKS now, I can see that there's been new changes. I can view those changes. And I already know that the changes are going to be based on those components. So I don't have any changes to my board outline, but I do have these new components. And if I click on them, it'll show me a preview of both the component and where it's going to go onto my board. All right, so go through and just accept those components. In the real world, I'd be a little bit more critical of where these belong and what I'm actually adding into my assembly. But for the sake of time and just the experience here today, we're going to go ahead and accept all these. All right, so I'll accept them. And what you'll see is why our original design was a assembly. So now what it's going through is finding these components and actually placing them based on the placement of our PCB. All right, so it's grabbing each component individually, adding it into our assembly, and in a couple seconds here we'll see our completed assembly with all our components placed in the correct locations. All right, so we got a pretty big board for the number of components we have, but that's all right. It still fits inside of our main computer assembly inside of our electrical project. All right, so you see now it's applying some holes to those components that actually go through the board. And that looks good. So with that updated, I can now jump back into my full assembly. And we'll see that all my components are now placed inside of my 3D space. All right, and these are the connectors that I want to add to electrical where I can route to and from. All right. At this point, I can actually still make changes to my board. So I can add any cuts that I need to. If I'm looking here, I realize that that's an interference that I'm going to need to create a cut for. So I'll just do one as a quick example. I can take my board outline, and I actually want to edit that part in the context of this assembly. All right, so I'm working on just this board part, and I'm going to create a new sketch. And let's say this is the hole that I want to create. I'm in my sketch mode. I can use my mouse gesture to make a quick circle. And I'll use my S key to make a cut extrude through this board. All right, so a cut on a PCB, so when I'm using that board outline, every cut has to be an individual entity because it's going to register as a hole back in PCB. All right, so with that one hole, I can now go back into my full assembly, and I can go ahead and push that hole, post it. It's going to push that back to the server. I can go into PCB, see that there's a new change, view that change, and go ahead and accept that cut. And what I now get is a new hole in my PCB. So these two softwares are constantly talking to each other based on any changes either the electrical person or the mechanical person makes. All right, so now that I have my PCB inside my main assembly, I need to add connectors to allow the wires to talk from the PCB to the rest of the computer model. All right, and the way I'm going to do that is using connector symbols and wires inside of SOLIDWORKS Electrical. All right, so I have an electrical project that already has components. We already saw wires routed and harnesses wired, routed inside of that workbench assembly. What I want to focus on here is I have one connector from my chassis, my 2U chassis, that's just floating right now. All right, so I want to add a new connector to this wire assembly that's going to allow me to talk to my PCB. All right, so I'm going to insert a symbol, and right now I'm just using a 6-pin symbol, and I'll go ahead and place it on my top wire. And functionality of SOLIDWORKS Electrical is it's going to ask me for a manufacturer part. All right, so I'll go ahead and search for a manufacturer part that's going to have 6 terminal connections in it. All right, so I'm looking for a Molex part, and this one has 6 terminals, 6 circuits. That's the one I want. I'll go ahead and add it and hit OK. All right, so that brought my Molex part in, and I'm going to make an internal connection as well inside my assembly. I'm going to grab one more symbol, I'm sorry, not inside my assembly, inside my PCB. So I want to have connectors talking to each other on the PCB. So I'll go ahead and grab a 6-pin left here. We'll drop that down, and same manufacturer part, we'll use that throughout. Grab our 6-pin, we'll add it, and OK. And now what's nice is I can take these wires, because I want to reuse them, as well as this connector. I can do a Control-C and a Control-V. It'll paste my connector, and you'll notice that my connector here will update to connector 4. So even though it's a copy and paste, it's not going to steal connector 2. It's going to create a new connector for. I'll go into my process. I'll number my new wires that I created down below, and there we have it. So we have our new wire numbers, and we have our new connectors for our model. Okay. So now I want to go into SOLIDWORKS. So I drew my wires. I selected my manufacturer part. Now I want to go into SOLIDWORKS and start to work with the model that I created. All right. So we'll minimize this, and we'll minimize this, and we'll be working with our SOLIDWORKS Electrical assembly. All right. When I'm in a SOLIDWORKS Electrical project, you'll notice that I get a SOLIDWORKS Electrical Manager here. My Electrical Manager is what I call the to-do list. So it shows all the components that I have in my schematic, and I can actually hide the ones that have already been placed, and it will just show me the components that I need to still place. All right, so they're my missing components inside this assembly. So what I want to do prior, so I still have a lot of components to still place. If I'm confused about which ones are for my project, I can actually create, or for my PCB, I can actually create a location back in electrical to help organize that these are my PCB connectors. So I'll jump back into electrical. And what I'm going to do is use a schematic feature called Location Outline. And I want all three connectors that I just created to be part of my PCB. So I'm going to just draw an outline like so. And I'm going to create a new location inside my workbench. So inside the hierarchy, I want this location or sub-location to be, we'll call it Tom's PCB. So this is the part that I'm creating. I can go a step further and actually assign a PCB part to this component. So I just created a simple CADimensions PCB. And now what that means is when I run my bill of materials, I'm actually going to have that PCB part that's being generated in SOLIDWORKS PCB in my electrical bill of materials and inside my electrical project. All right. So I want to change those components that I just created to be inside of this new location. And I'll do just a little bit of cleanup work here, and we'll slide that to the top here. Now I know that these three components are inside my PCB. And if I go back into SOLIDWORKS, you'll notice that I now have this location. Again, the information's updating constantly, and I can see my three components now are linked together. I can also go ahead and associate that PCB board that I've been designing to the component. All right, so now that whole assembly is assigned to my bill of materials. The Molex part that I created for these three connectors has a 3D model associated to it. All right, so what I can do is I can come in, I can right-click on that component and insert it. And you'll notice that it's just kind of floating there. So it's coming in as an entity, but it's not snapping to my component. It's not really helping me quickly create this assembly that I want to create. All right, so we can just see it's floating there. And I can certainly go through my assembly functionality and create my mates that I need to mate. So I can say that goes to that face, and this is going to go, so our top of our face here is going to go to the top of the face here, and that should be aligned. And finally, I can slide this over. So I can make those three mates, but I know that I have three more components coming that are exactly like this. I'm probably going to have other projects that have components that are exactly like this. So what I want to show you next is how to make this connector a bit smarter that I can quickly come through and generate a quick mate with routing potential. All right, so the first thing I'm going to open up is my component from my PCB. All right, so it pulled it out of a user library. So right now, this is just a component that got pulled from a library. And it's really just a dumb solid. All right, so it was downloaded from a manufacturer website, or it was created by another user and shared. Somehow we got it in probably a step form and brought it into SOLIDWORKS. What I want to do is create a mate reference to this component. All right, and the way we do that is from our features menu and reference geometry, we have a mate reference where we can actually come in and create a name. This is going to be our connection. we can start to pick some references that we want to use for our component. So I want to mate my right side of the component to be a coincident mate, and I want those faces to be aligned. And we'll see what what our alignment and our mate references mean when we go into our connector. I also want the top face to have a coincident and aligned mate. And then my third or my tertiary mate that I want to create is the inside of this connector, where again I'm going to have a coincident, and this one's going to be anti-aligned. So what I'm telling it is I want that slot to be facing out for my component, or for my connector. I want the top of it to be level here, and I want it to sit inside of this, to this male mate. I'll go ahead and accept that mate reference. We can see that I now have that connect mate reference. I'll save. I can close out of here. All right. And now I want to do pretty much the same, but the inverse of those mate references to this component. All right. So same process. I'll go into reference geometry and mate reference. And my first, or my primary, actually I'm going to change my name to connect to match the other. My primary is going to be this face, which was the outside face of the female side. I'm sorry, the male side, and that's going to be a coincident and aligned. My next face is going to be the top, which again is coincident and aligned. So we want those facing the same direction. And finally, the outside face of this one is going to be coincident with the inside face, or anti-aligned, of my male side. So go ahead and accept that. We can see our mate reference now with the connection here. We'll go ahead and save it, and we can close out of this. Now what this means is the next time I come in and place a component, so if I we'll place component C4 next. If I come in and say insert, all I have to do is hover over this component, and all three mates will snap to it immediately. All right, and we can see that that gets assigned. So looking back at my schematic, I just want to make sure I have the right parts going to the right place. So C2, C3, and C4. So my C2 should really be at the bottom of my board. So that was this guy. All I'm going to do is hit the delete key to remove it. Not really the end of the world, because now I have that smart mate, and I can hover over, snap to it. And same with down here. I can insert, hover over it, and snap to it. All right, so the final thing I wanted to show is how to route wires. So I now have a PCB with connectors connected to it. I have a schematic from SOLIDWORKS Electrical that shows how these wires interact. The last thing I have to do is actually create some connection points so I can route these wires. So I'm going to jump back into my model here, my connector model. And I'm going to use my electrical component wizard. So under Tools, SOLIDWORKS Electrical, and my electrical component wizard, I'm not too concerned with the faces or my mate references because I'd made that smart mate already. But I do want to create connection points by a reference. And that reference is going to be the Molex connector that I'm using inside of my schematic. All right, so I can come through and assign connection points to each terminal inside of my Molex connector. And you can see my numbering scheme is going to match the circuit and terminal information of that manufacturer part. All right, so all I'm doing here is saying where a wire should be running into this connector. All right, so a couple more. Some of these connectors will end up being cables. So this is where individual wires are going to route to and from. So I'm good with that, and I can leave the command. If I want this to break out into a cable, all I'd have to do is add a quick plane, and I'm going to sketch on that plane, and all I'm going to do is throw down a point somewhere in the middle. What I can do now is go back into my electrical component wizard, and instead of creating connection point by reference, I'm going to create a cable connection point. I'll choose that point. And now what this means is the cable will run into here, and my wires will run off of that. All right, So I'll save that, and we'll close. And again, SOLIDWORKS being parametric means that all those connection points, even though I updated one, are now going to be applied to all three of my connectors. All right, and if I want to see those connection points, I can go ahead and turn them on by turning on my view routing points. All right, and as I hover over them, they'll start to appear. I can also go ahead and turn off those planes if they're in my way. All right, so I think I'm finally ready to route here. I can see that I have a path or a route path for these components, but they don't quite reach my board. So I'm just going to make sure that I edit this route, or edit this sketch, which is the path that allows me to route on. And I'm just going to add a couple lines using a 3D sketch to make sure that I'm going to make it out to my PCB over here. All right, so just snap a couple lines quickly. Rotate a little to make sure I'm lined up. So I'm just going to make sure that I have a path that can get to these components. All right, and we'll throw one more just to come up a little bit here. Okay, so that looks pretty good. I think I'm ready to route. So based on my schematic, I should be coming off of this connector into connector 2, and then these two are going to be internally wired between 3 and 4. All right, so I'll go into SOLIDWORKS Electrical 3D. Actually, I'll leave my sketch first here. So that path is now updated, so it's closer to my PCB. And I can go ahead and route my wires. I'm just going to do a quick 3D sketch route of all my components. And the 3D sketch route is going to be a little bit quicker because it's not applying geometry to each wire, where a SOLIDWORKS route will apply the correct diameter or gauge of a wire as it's routing. A 3D sketch allows us to see it quickly, just to verify that our wires are going to be in the right place. And what it also allows us to do is gives us length when we go ahead and route or run a report inside of SOLIDWORKS Electrical. All right, so I can see that my wires are coming to and from these components, as well as my internal setup that I had before. I can see that my wires are going between these two connectors that I had in my PCB. All right. So I really wanted to keep this one to a half hour. I wanted to make sure that I was covering the 3 pieces of software that we used, which is SOLIDWORKS PCB, SOLIDWORKS Electrical to create those manufactured parts, the connectors, and the wires, and then SOLIDWORKS to integrate everything in that ecosystem to say I can take a PCB, make edits to it in a solid model, push it back into a schematic or into a 2D model, and have that interaction between our mechanical and electrical guys really across the board at this point. So having the electrical engineer, the board engineer, and the mechanical engineer all working out of the same interface and same project, so we don't have to wait to the end of a project to realize something's not going to fit or something isn't going to interact correctly. All right, with that, I'll open it up to questions. If you're still interested in SOLIDWORKS PCB, I threw a link out here to a webinar Kevin and I did a couple weeks ago. It's also right on our CADimensions YouTube channel. So if you just search PCB, it'll pop up. Any specific questions outside the scope of this, please feel free to send me an email. Let me know what you think about any of the 3 products I talked about today, and I look forward to hearing from you. Thanks, everybody.
Don't forget to check us out on YouTube, Twitter, Facebook, and our blog for more great content by clicking on the links in the description below.